Hello everyone, I'm Toby Lee from CMU, and today I'm happy to be here to present my work on PUMICE, which is a multi-modal agent that learns concepts and conditionals from natural language instructions. As we know, intelligent agents like Siri, Alexa, and Google Assistants are getting more and more popular. They can perform tasks on users' behalf. However, a problem is that the agent sometimes doesn't understand what the user says or doesn't know how to perform the task the user asks for. A solution to this problem is Enduser Development. We can have users to teach the agent what it doesn't know or can't understand. And Enduser Development is actually needed. Although existing agents like Siri or Google Assistant provide developer tools for professional app developers to integrate their own apps, this process takes significant engineering effort. Prior work, as well as our formative study, found that there's a huge long tail for apps and mobile tasks. This long tail is not currently supported, and much of it is unlikely to get professionally developed in near future due to the effort required. When the agent doesn't understand the command, there are two possible reasons. For example, here, if the user says, if the weather is hot, order a cup of iced cappuccino, the agent may either not know the concept hot or the procedure of ordering an iced cappuccino. While it's not a focus of this paper, a lot of prior works have been done in demonstrating in learning procedures. For example, at KAI 2017, we published a Sugarlight system for learning procedures from mobile app demonstrations. In this work, we also use Sugarlight for implementing the underlying mechanisms. There are also prior works such as CodeScripter and Plow that used a similar approach on web interfaces. Another approach is to have the user verbally break down the task into steps, assuming the agent knows how to perform each individual step. Or it can use visual programming approach to have the user create a flowchart of the procedure. In this paper, our focus is on learning concepts like what does hot mean. Similar to procedures, it's possible to have the user verbally explain the concept, but a caveat is that it requires the agent to already know some other concepts that the user might use to explain the first one. If the agent doesn't have sufficient knowledge about the task domain, then the user often either can't provide additional information because the user doesn't know what the agent already knows, or the user may introduce even more unknown concepts when trying to explain the first one. Another approach is to have the user provide multiple examples, and then the agent can use program synthesis method to infer a program that satisfies all the constraints in the examples. However, many prior studies have shown that non-programmers are usually not that good at providing useful examples. They often will give ambiguous ones, or they will give examples that are essentially the same to the agent that will not cover the whole problem space. There's also the visual programming approach. While this is easier than conventional programming, it still has a notable learning barrier for end users. To help us design a new approach, we conducted a formative study on Mechanical Turk. We asked workers to describe a task automation rule to an intelligent agent in natural language. To avoid bias the user's language, we showed prompts in graphics instead of text. This is known as the natural programming elicitation method. We divided the workers into two groups. The experiment group were shown the screenshots of the relevant mobile apps, like in this case, the weather app and the Starbucks app. And the control group didn't see the screenshots. Our hypothesis is that app screenshots can help them with describing the task. Here are some of our key findings. Unsurprisingly, users often use vague, unclear, or ambiguous concepts in their instructions. And users often assume that the agent will have some common sense knowledge or some common sense reasoning skills, like they expect the agent to know the meanings of good weather, busy day, heavy traffic, or that one user mentioned uneasy class, which means that a class has a higher average score. Between the two groups, users who saw app screenshots used significantly fewer vague, unclear, or ambiguous concepts. They also tend to use the language and structures from the app screenshots they see, which would make natural language understanding part much easier from a systems perspective too. These findings confirmed our earlier hypothesis. App GUIs can help end users specify concepts in their natural language instructions. From this idea, we designed and developed a system named PUMICE. It's named after a type of rock that looks like that. And it's an acronym for programming a user-friendly multi-modal interface through conversations and examples. We took a multi-modal approach where we had the user start with a high-level natural language instruction, and then the user can recursively classify any ambiguous, unknown, or vague concepts through natural language conversations and references to GUIs of third-party apps. We identified two key design goals. We want the PUMICE to be able to learn generalizable concepts that can be reused in different contexts and text domains. We also want the system to be easy and natural to use for end users without programming expertise. Here, let me show a video of how it works.
If the weather is hot, order a cup of iced coffee.
How do I tell whether the weather is hot?
When the current temperature is above 70 degrees Fahrenheit.
I think what you meant is, the value of a concept current temperature is greater than 70 Fahrenheit. Is this correct?
Yes.
How do I find out the value for current temperature? You can explain or say demonstrate to demonstrate.
I will demonstrate.
Please start demonstrating how to find out the value of current temperature. Click OK to continue. Do you want to record the operation? Do you want to record the operation? Set value of, OK, I learned how to find out the value for current temperature. OK, I learned how to tell whether the weather is hot. How do I order a cup of iced coffee? You can explain or say demonstrate to demonstrate.
I'll demonstrate for you.
Please start demonstrating how to order a cup of iced coffee. Click. Do you want to record the operation? 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 Click on the item. Do you want to record the operation? Click on the item. Okay, I learned how to order a cup of iced coffee in Starbucks. Should I do anything if the condition, the weather is hot, is not true?
Order a cappuccino.
I've finished resolving all concepts. Below is the updated list of existing knowledge. I've understood your instruction. If the condition, the weather is hot, is true, then perform the action, order a cup of iced coffee. Do you want me to execute it now?
Yes.
Executing the script. The value of current temperature is 86 degrees. The condition, the weather is hot, is true. Executing the procedure, order an iced coffee.
So you can see here it has already learned how to manipulate the GUIs to get the value for temperature and to order coffee. So this figure shows the conversation structures for the interaction you just saw. It's a top-down structure with laser evaluation. So let's look at top. The agent basically recognized the conditional structure, but it didn't understand either the condition or the action. So you use those resolve function to represent those. You can see those resolve functions are typed. So you can see the first one expects a Boolean value, and the second one expects a procedure. The system then recursively resolves those functions in a depth-first way. Along this process, it learns concepts like those Boolean functions, value queries, and procedures of performing tasks. They are stored in a persistent knowledge base, which I will explain later in more details. PUMICE uses type-based highlighting to help user demonstrate value queries. For example, at this step, although it doesn't know what commute time is, it knows that it should be a time value that's comparable to 20 minutes. Therefore, in the demonstration, it highlights all the time values on the screen to ensure that what the user selects can fit into this expression with the compatible data type. A key goal of PUMICE is to generalize from what it has learned, and there are different levels. It learns 3 kinds of knowledge and stores them in a knowledge base. There are procedures of doing something, like ordering an iced cappuccino. For them, it supports parameterizations so that it learns how to order any kind of drinks by looking at the GUI structures of the Starbucks app. The second type is for concepts. In PUMICE, concepts are context dependent. For example, the concept hot in if the weather is hot, order iced coffee is very different from if the oven is hot, turn down the oven. PUMICE can generalize the concept hot to a temperature is greater than another temperature, and associate the actual implementation to specific task domains. So now if I introduce a new task, like I say, if it's hot, remind me to bring a jacket, it will ask, should I find out if it's hot using the weather app, the smart oven app, or something else, and then ask if there's a new threshold for reminding me to bring a jacket. There can also be multiple value query implementations for the same value name. Like when we say temperature, there can be multiple ways to find out the temperature, depending on if we're talking about the weather or the oven. Another challenge in generalization is the data description problem. When the user points to an element on the GUI, the system needs to generate a query for identifying the target element in future executions. For example, when the user points at this element, the system needs to figure out if the user wants to record this action as selecting the item at this exact pixel location, the item that has the exact string, 81 degrees, or something else. Our approach is to ask the user to describe the ambiguous concept in natural language. For example, here, the user can say, oh, this is the current temperature of the city. The system can then correctly interpret this action as selecting the item that shows a temperature and is below the name of a city. We did an in-lab user study to evaluate the usability of our system. We had 10 users, including both programmers and non-programmers. We gave each of them 4 tasks in random order, and in each task, they teach the agent an automation rule with a condition, as well as the associated value queries and actions. To avoid bias in the language, we represent the task prompt in graphics. Here are 2 examples and some possible natural language instructions for those examples. The study results were encouraging. All participants were able to complete all 4 tasks. In the post-survey study, participants reported that they found SUGLite easy to use, natural, and useful. There was no significant difference in time on task between programmers and non-programmers. They on average spend around 5 to 7 minutes for each task. This suggests that non-programmers can use PUMICE as well as programmers. For future work, here are a few directions. We're currently working on having more robust natural language understanding so the system can understand more flexible utterances. We're also looking at ways to aggregate knowledge learned from multiple users. A major challenge here is to differentiate generalizable knowledge from user personal preferences. We're also developing new error recovery systems, and our final goal is to have a deployment study so we can understand how users actually use PUMICE in their real life, what tasks they use it for, and how they discover those needs for automating tasks. With that, I would like to conclude my talk. Thank you for your attention, and I'm happy to take questions.
I love your example about hot, where it means really different things for weather and the oven. And one thing I was wondering do you imagine that there would be some things that a system like this would have built in? Like, I feel like every phone basically knows what the weather is, whereas it seems much less likely, unless your phone is made in Seattle, that it would automatically know what the weather is.
Yeah, that's a great question. Like in the talk, I used an example that most people can relate to, but I agree with you that this is something the phone should be able to have it built in rather than having the end user to teach it. But when we did our formative study, I talked to a lot of users and I asked them, can you give me something that if I gave you this tool, what would you like to automate? The funny thing is they are all able to give me something, but they all come up with very different examples. And a lot of those examples are very specific to that particular user's personal conditions or professions. So like, for example, when I talked to a system administrator, like he told me he always check up like the AWS app to check the status of his server. So he would like to have the agent to do that for him. So as I said, there's this huge long tail of tasks and scenarios. So I think even if we reach a point where the phone has most of the common concepts already built in, there's still space for end user development.
Hey, really good talk. Jia-Jun from UW. And I have a question. So in your condition, you have the judge based on the app interaction. For example, if the weather is high, then you open the app and then tell the robot to recognize the value.
Right.
But what if the concept cannot be told using the app interaction? For example, like some question like when I feel sad, and there might not be an app to indicate the concept, or like when somebody, I don't know, like goes out, it might be, or like using searching on Google, Google might tell you the answer, but it's not in the app. So have you ever considered these cases?
Yeah, that's a great question. Yeah.
I see two more questions. So both your answers and our questions can be brief. That way we can get all of them before the next speaker. So let's let the next speaker set up.
Yeah. Great question. So currently a limitation is that we only support those very straightforward and explicit rules. So, but I mean, after all, it's very hard for even a human to tell if you're sad or not, right? But I think a relevant area that I'm seeing a lot of work going on in machine learning and natural language processing is to learn more fuzzy rules from natural language instructions and trying to learn a classifier from those fuzzy instructions. So that's something I think we can look at for future work.
Yeah, can you say a bit more on the trade-off of domain-specific nature of this approach versus like machine learning or data-driven approach, where if you narrow the problem down to small enough of either a domain or a task procedure, that machine learning can possibly do pretty well. The trouble with Google Assistant or all these things is that the actual use case is quite broad, and your approach seemed to be better at it, but yet it still needed fairly narrow domain to teach the agent.
Sure.
So the trade-off.
Apparently, a limitation of the end user development approach is that it requires basically more effort from the end users. But I think the one advantage is that it provides basically more control to the end user. So the end user have a clear sense of like what behavior to expect. And it has basically better capability to edit the existing scripts or to basically to embed personal preferences into those scripts. But I think in the future, I'm more envisioning of a hybrid approach where a machine learning system can learn like more general patterns of apps from maybe a larger number of apps. Like here are a general procedure of buying things using apps that offer those options, and to understand basically the semantics of those like widgets and UI layouts. but also provides users like opportunities to customize the procedures through some sort of end-user development approach. That's what I envision.
And let's see if we can be real quick. You're good? All right. Thank you. And